Welcome to the weekly challenge videos. If you like this kind of content, please like or subscribe. And if you'd like to see even more of these challenge questions, I have a lot more on my courses website, link in the description below. Okay, a plunger accelerates a ball starting at rest with a constant acceleration over a distance delta x. The ball then continues with constant velocity, rolls off the end of the table, and lands a distance d from the table. The height of the table is h. Derive an expression for the acceleration of the ball caused by the plunger. Okay, so here the quantities are giving us delta x, d, and h, and stuff like this. So what do we need to know? Let's talk. There's two motions. One is the first motion where he kind of moves a distance delta x over a constant acceleration. So that's just a single horizontal motion, not a projectile motion. Single horizontal motion. Let's take a look at the first motion, the plunger motion. Okay, the displacement we know is delta x. The initial velocity is 0. The final velocity is unknown. The acceleration is what we're trying to figure out. And the time is also unknown. So you see, I only have two known quantities, delta x and 0, and I cannot figure out the acceleration from here. I need either the final velocity or the time. So not enough information. So let's look at the projectile motion scenario. So the projectile motion. Let's look at the x variables. I know that from here to here, it traveled a distance d, horizontal distance d. The initial velocity is unknown. The final velocity is also unknown. The acceleration is 0, and the time is unknown. And in the y direction, I have the vertical displacement. Let's say down is positive and to the right is positive. So if down is positive, it fell a distance h from there to there. The initial velocity in the vertical direction is 0, because right off here it's rolling horizontally. Final velocity is unknown. Acceleration is negative g, or positive g, because I said down is positive. So positive g, and t is unknown. Okay, so what do we want to figure out here? Well, you see, the thing is the initial velocity here is going to match the final velocity over here. Because what's going to happen is it's going to accelerate, then it's going to move with the same speed, constant velocity, to here. So whatever initial velocity it launched it with here, I can use for the final velocity here. And once I know this, then I have three variables I can use to solve for the other one. Right? So if I'm looking at it from that point of view, what I'm trying to figure out is what the initial velocity is, what this velocity is here. So from here, I need to find time. Here I have h, this is 0, equals 1/2 gt squared. So t is equal to root 2h over g, right? Times 2 divided by g, and then take the square root. Plug that into there, and here we would have d is equal to v0 times root 2h over g. Dividing that to the other side, v0 would equal d over root 2h over g, which you could also write as d times the root of g over 2h. Just make the reciprocal of there. So that goes into right here, d root g over 2h. Now that I have that variable, now I can use my kinematic equations. Now I want to figure out the acceleration, so I'm going to use this equation because I don't have the time, right? And I want to find a. So solving for a, you would get v squared minus v0 squared over 2 delta x. This squared is d squared times g over 2h minus 0 squared divided by 2 delta x. So just putting that together, that's gone. That's just 0. Move that into there. It's going to be d squared g over 4h delta x. That's what the acceleration is. Okay. Sketch the graph of the speed of the ball as a function of time, starting when the ball is pushed by the plunger and ending when the ball hits the ground. Okay, this is an interesting question. So the speed is gonna move at constant acceleration upward. Now you don't know any number, so you just say constant acceleration upward. Then it's gonna roll flat on the table to this point. And then it's like, okay, what's going to happen here is it's definitely going to increase, but how is it going to increase? Well, the velocity, the speed, the horizontal speed will be constant, right? but the vertical speed will increase. So if I look at like kind of the total velocity, which would be the square root of the vx squared plus vy squared, right? That's the speed. This is a constant, and this is so it should kind of go up kind of linearly, I guess. Like that's a constant, and then I don't know. The exact shape would be kind of weird, but I think linear would be a reasonable shape. This is a little tough. It's a square root of a fixed number plus something squared. So it's a little tough. It looks almost kind of like a square root. It'll look kind of constant, but it will like kind of, I think it will kind of do something like this. Because the speed will then increase. It'll be kind of like this weird shape because what will happen is initially the Vx is going to be like V's Vy zeros is going to start there, and it's not really going to change much. It's going to go up incrementally a little bit, but then as Vy gets very big compared to Vx, it'll look kind of like it'll like kind of straighten out. So that part's a little tricky to understand where that was. But if you got the first part, that would be the key part. But you just have to remember this is a fixed value, and this will increase as it falls. And so that's what the shape of this graph would look like.